So just like before I get started, how many of you guys are technical? Just so that I can gauge. Okay, are you guys like new to Web3 or like quite deep? New? Anyone new? Okay, cool. So I think like you guys are probably kind of familiar with crypto already. But yeah, like today's workshop, I'll just basically show you guys how we can build with Cosmic RNG. So anyone here familiar with random number generators or like Chainlink VRF? Anyone heard of it before? Yep. Okay. So basically, like if you want to do something on chain, and you need like a random number generator, for example, like a lottery or any other kind of application, you need this kind of like RNG. But what we are building is a cosmic RNG, which is basically coming from like cosmic radiation. So it's not actually like pseudo-randomness, which is usually like derived from your CPU and stuff like that. But yeah, just a brief introduction about like what SpaceComputer is. SpaceComputer is essentially building a cryptographically secure compute protocol for any blockchain. So what we're doing is we're launching TEs into space. TEs are trusted execution environments, and we're going to have a network of these space TEs. And essentially, like all of these TEs can run smart contracts, and we're also building an economic layer where you can essentially have a marketplace and people can do payments in order for you to like host smart contracts over there or even like just run them. So why space TEs and also like why now? It's because like if we launch computers into space, it's technically more secure. There's a layer of like physical isolation. If you are hosting a server on Earth, it's easy to break in and like destroy that data center, or maybe earthquakes or like some natural disaster. But in space, theoretically, it's much more difficult for you to get out there and try to like take down one of those satellites. And also, like within the past 2 years, we've actually launched more things into space than we ever did for the entire like century. So yeah, that's why we're doing things in space. So right now we only have one space TE, and in order for you to communicate with it, you got to use our gateway called OrbitPort. So you can call it through an API, you can use an SDK, but I'll show you guys how to actually use it on chain. So we have sort of like a two-tier architecture. Because of the latency of like communicating with like space satellites, it wouldn't make sense for you to actually like execute transactions in space. So think of the space layer as your L1, and we will find like a suitable L2 in order for us to like handle all of the transactions and then just like bundle everything and push it back into our L1, which is our celestial chain, and essentially like that will be your source of truth. So yeah, like this is a little bit more on like cTRNG. It gets a little bit technical, but basically the satellites right now are run by a company called Aptos Orbital, and that's where we're getting the randomness from. And then basically like we'll just aggregate all the values, batch them, and then push them into like an IPFS beacon that you can retrieve these values from. So yeah, there's a lot of things that you can do with SpaceComputer and even with like cTRNG itself. And if you're wondering about like the pros and cons of cTRNG compared to like VRF, one thing is that like we are, as I mentioned, true randomness compared to like pseudo randomness. Space-based infrastructure, again, we have the physical isolation, and we're running everything in a TE. So even if the host or the hypervisor is compromised or malicious, you can be rest assured that your everything running within the TE is still secure. So yeah, I've not done a workshop or attended a workshop ever since AI became a thing. So I don't know how people react to live coding. Does anyone actually want to code together, or are you guys just listening? How many is going to code? Because I only see like a few laptops. Okay, so I'll show you guys how to interact with it. For those who are not coding, feel free to just listen along. For those who are coding, once you guys get the hang of it, feel free to just like vibe code something. I may not touch on the front end depending on time. But yeah, so back to our OrbitPort and cTRNG, there's actually a few ways to interact with it. I know it's a little bit tiny, but I'll sort of like just explain it for you guys. One is through API. So you can call OrbitPort directly, but you need an API access key. You can get that from like our Telegram channel. I'll give you guys a QR at the end, or you can get it directly from IPFS. So again, we bundle and push all of these into IPFS every minute. So technically, like even without the API, you guys can get it from IPFS. But do take note that it takes 1 minute for it to refresh. But on OrbitPort, every time you make a request, you get a new random value. And then lastly, on-chain. So we are partnering with eOracle, and eOracle is basically going to host a network of data validators that pull in all of these values, aggregate them, and then push these values on chain. The entire infrastructure is still being set up. So for this demo, we actually have a sort of like a replica of what it will be like once eOracle fully supports us. So the interface, everything is the exact same. It's just that there's certain things that are not optimized yet. So we have a pool-based Oracle. And so like for Oracle systems, for those who don't know, there's push-based and there's pull-based. Push-based is when you're requesting for like a random value and then you can get it back. Pull-based is like that data is already there. So you're just pulling, you're fetching data from it. Most of the time, like Chainlink VRF, you would use a push-based Oracle. But again, because the infrastructure is not set up yet, so we have a pull-based Oracle. So it's a little bit funny because it updates every minute. So you only get a random value every minute. But you can always like add in your own entropy, like or timestamp or anything else, just to make it more secure. Okay, so for those who have their laptops out, feel free to scan the QR and yeah, you can basically redirect you to like GitHub. So once you guys got it, then I'll sort of show you guys the code. All good? Okay, so is it too tiny? Should I make it bigger? Yeah. Oh, did you guys go to this one? No? Oh, my bad. Okay, never mind. This one works too. Okay. So feel free to clone this repo. So once you clone it, you essentially have like a dApp folder and a front end folder. And that's where we'll sort of be building things out of it. Yeah. To give you guys more context as well, we have a repo called like OrbitPort Oracle. This is not the finalized version, but basically like if you scroll down, you'd see the deployed contract address. Right now, we only have it on Arbitrum Sepolia. But of course, like in the future, we'll support every other chain. I'll show you guys what it looks like here. So you can see that there is sort of like data being updated every minute. Um, and yeah, like if you want to read from these contracts, um, you can basically just, I don't think I need to connect, but cat feed. Yeah, there you go. So right now we're using feed ID 0 because we're the only ones pushing to this contract. And so like if you query it, then you get a uin 256 random value that you can do anything with. Yep. Okay. Any questions so far? Or like, should we do it at the end? Okay. How many more minutes do I have? Okay, that's enough time, I think. Okay. Cool. So for those who are coding along, we can go into the dApp folder. This is using Foundry. Another thing with like workshops is that you always have to like set up all the tools. So if you guys don't have like Foundry or anything else, you can set it up after this session, but I will show you guys what you can do first. So this is just a dice game, but of course you can do anything else. It can be a coin flip. It can be like picking a number 1 to 10. It could be anything. But yeah, like basically all you got to do is you have to connect to eOracle's feed manager. And so like if you have Foundry installed and you run install, it should install everything straight away. So that includes like this interface here. I'll show you guys what it looks like if I can open it. Okay, so this is basically like the standard interface for eOracle. I'll probably make it bigger. Any like Oracle feed data that's like pool based that we push to eOracle would be basically like interacting with this contract. So whatever we're doing now, even though it's not on their infrastructure yet, but once we do migrate it over, it will be exactly the same. So yeah, there's a lot of things like within this contract, but again, it's like coming from eOracle. So you have to like connect to it. And one way is like through the constructor. So we'll just initialize the feed manager itself. And so like you can do all sorts of things that you want. So for example, like let's say I want to create this function called bet. So thanks to AI, I can code at the speed of light. And like, yeah, so you can just store your bets. But like, of course, customize this function as much as you like. I'll show you guys how to get the random value. So let's say I have a function called resolve. Oh, wow, there you go, AI. So yeah, all you got to do is just IEO feed manager dot price feed, and then yeah, basically like we're storing the price feed data itself, and we're getting the latest price feed, and the feed ID is 0, which we're storing up here. So once you have all of that, and then like again, like because I'm doing a dice roll, so it's between 1 to 6. But of course, like if you want to do like 1 to 10, it could be anything. Um, and then like yeah, that's basically it. You can retrieve your random values. In order for you to deploy this, we would have to go to the deploy script. So inside here, and you can just plug in the address, which is actually like this address. And yeah, like you can just run forge. Oh, there you go. So you can just do like forge script, um, script. I'm sorry, forge run script dice game. So game, and then you can pass in the RPC URL, which is from Arbitrum Sepolia, because we're already supporting that. And then after that, like you basically have a dice game deployed. Yeah. So I know it's a really quick demo. If you guys have any questions, feel free to ask me after that. Oh, you don't get the dApp? You don't have a dApp folder? Yeah, so this cTRNG dApp demo. Yeah, but if you want to test it out on chain itself, best way is through like going to the block explorer and just clicking it. Yes, sure. Yeah. Yep. Okay. So when you mean like writing, do you mean like to this smart contract or to the TE?
Well, whichever, like, so you got a random source and you're
Yep.
inputting into this contract, and then someone pulls from this contract, right?
Yep.
So when you have two devices writing into it, right, the second one,
Yep.
right, how does that, how do you know if that second one is a legit source,
Yep.
right? And then secondly, if there are two, then what happens to the random numbers? Are they like both inputs used to compute the output, or
Yeah. That's a good question. Okay, so for the first one, so we can see this data validator here. So basically, like that data validator is just doing a query using like our SDK into the satellites. We're getting the random value, and then after that, we're just pushing that on chain right now. And in your question of like having two satellites, we haven't actually decided what we're gonna do about these two. The thing is, because cosmic entropy means that is technically somewhat non-deterministic, but there is a way to validate that the randomness that we're getting is from cosmic entropy itself. There's a certain library that we're using to do that validation. I can't remember what it's called, but yeah, we can either like hash both of them together because we have the aggregator right here. So we can either like hash all of it together and just push it. But one thing that we're also doing on our IPFS now is that we're pushing all the cTRNG values. So every minute, you can see 3 values, but in the future, like it could be even more. Cool. Yes.
I'm not very techy, but so excuse me if my questions are stupid, but I have two questions. Firstly, um, how do you legitimize or are there, or how do you say, are there trade-offs for putting the main L1 on into the space worth it? Worth the latency from here, etc., the cost? And secondly, if you're going to do something like DeFi there, won't it give advantage to anyone who launches another space computer which interacts with your DeFi and has lower latency than?
That's a good question. So the thing is that like what I mentioned earlier as well, most of the execution will actually happen on the L2. So the L2 could be anything like Base or Arbitrum or any other like protocol, and then we would actually push and bundle those values back into our L1. So ideally, we would be creating our own L2 as well. So for example, like using Arbitrum stylus or anything else. And then after that, we will actually just push those values to our own L1. So most of the settlement just happens on the L1, but latency wise, because that's gonna be on the L2 side, so like it wouldn't affect whether you have a satellite or not. Did I answer all your question? I feel like I missed one. No? Okay. Yep.
So one question is how to guarantee liveness of the L2 dice because like not sure any incentive or some mechanism.
Of the L2 itself?
Yeah, for example, suppose I use the application for guarantee. The random number is really frequent, constant upgrade. And second, actually,
Yes.
is related is how to guarantee there's no from by running attack, so that maybe because that needs option to submit it, so I can
Mm-hmm.
know the like what's the result will be. So I probably will delay or maybe run
Yep.
ahead so that I can manipulate the random number.
Yep. Yeah. So again, similar to like the answer for Brandon is that there is a way to do the validation of the randomness through a library. But one thing is that we're also doing a threshold signature cryptography in order for us to actually perform validation that these values are coming from our satellites itself. But that's in the roadmap and it's not live yet. So right now, we're doing a lot of assumptions. The assumption being that since we are the only ones with the randomness, so we're not going to act malicious. But again, in the future, there's going to be a lot more providers for these TEs. Any other questions? Yep.
Yeah, so like considering the complexity, like what are the actual use cases for like real world?
In terms of cTRNG or
Yeah, like with all of this like complexity ensuring that the value is consistent. Like in real world application, like
yep.
what kind of application would this be perfect for?
Yeah. I think the biggest one is still in terms of security. So like if you are familiar with like threshold cryptography or like creating like private public keys, most of the time like you would need a source of randomness in order to generate your first pair of keys. So like that is what ideally we want to provide. But again, SpaceComputer is a protocol itself. So we see ourselves as a SaaS company because in the future, all of the satellites that are going to be launched into space won't necessarily come from us. So we will focus a lot on the consensus, the execution layer, essentially like treating ourselves as building a chain or a protocol. Yeah. Any other questions? Yes.
How do you deal with cosmic radiation in this case? So one of the issues of doing computers in space is that there tends to be bit errors. So if you're trying to do something higher value than just with random generation, like the physical construction of like the computer actually matters.
Yeah. That's actually a good question that I have no idea how to answer because sadly I don't engineer the tech, but I will get an answer for you and I'll let you know after this. Cool.
Very much.
Thanks everyone.
Well, a lot of questions, but if there are more questions, feel free to talk to Eason after this.
Oh, let me really quickly give you guys the QR.
Oh,
Okay, so Telegram is here. Blame the designer. I don't have control over the slides. Yeah, I'll just take a whole photo.